Hello, my name is Ashley Nyhan.
And I'm Antonia Hand.
Today we are going to be talking about center of mass in relation to males and females.
So the scientific definition of center of mass is, quote, the unique point where the weighted relative position of the distributed mass sums to zero. So for this video experiment, we are going to test out the different center of masses between men and women, while also trying to explain the physics behind it through a test that was widely popular on the internet quite recently.
It's called the Chair Challenge, and it's really baffling people.
Yeah, take a look at this video that has 7.5 million views on Facebook. It's from a Utah radio station, Planet 105.1. You see a bunch of girls picking up a chair with their head against the wall. The thing is, the guys can't do it. They can't stand up.
Right. So, of course, we had to give this a try. I mean, it's just what we do here. So, take a look.
The Chair Challenge is more than picking up a chair. First, you start with your feet together against the wall. Next, take 2 steps back in a straight line, put your feet together, lean forward. Your head has to touch the wall at all times. Slide a chair in, pick that chair up, and try to stand up. And let's see how we did. Danielle? Got it. Holly? No problem. Maureen? Those leopard heels didn't stop her. Then it was my turn. All right, the true test.
You gotta touch me. Yeah. Are you serious? You can't do it for real? You stand up. Just stand up. Stand up. Just stand up.
I can't.
Yeah.
You guys are even heckling me.
I mean, and truly, you could not do it.
No, and I wasn't alone. Look, Austin's really upset about this because he
Yeah,
thinks he
yeah.
can do everything.
Right.
He couldn't do it. And our
Austin's still
custodian,
like,
Dwayne, he tried. He couldn't do it either.
Right. So, what's the deal? You might be kind of curious. We turned to physical therapists at Metro Health for answers.
Some people think it has something to do with core strength or ability to bend in that position, and we think it is a lot more to do with center of mass and essentially how big the size of someone's foot is. So people with larger feet will put them farther away from the wall and extend their center of mass away from a position that their muscles can act as levers and move them across the anchor of their center of mass.
Makes sense.
Yeah, so Austin was so upset. He was like, that was his theory. He's like, damn, go farther back. And he like kind of pushed me back. And then when I did it, I couldn't do it. I couldn't. Yeah, so guys have bigger feet.
How many people are going to try that now today? And I am telling you right now, if you had $1 million right there and said, Dave, stand up and go pick up that money, I couldn't do it.
Right.
I mean, that's how real that is.
No, you really couldn't.
Yeah.
Well, you put your hand up there and got up there. He cheated a little bit to get up.
I did.
Make sure you're low enough, and then pull the chair to your chest and stand up. Chair, pull it to your chest, and stand up.
A man's center of gravity is located at the center of his chest at his sternum, while a woman's center of gravity is located approximately in the center of her pelvis. For example, handstands are a bit easier for a man, while a woman can more generally sense the ground and use it as her base of support.
So now I'm going to explain the steps in order to lift the chair and to do this experiment. So first you're going to want to stand with your toes touching the wall. Then place one foot immediately behind the other, and then you're going to want to take 2 steps back. Have someone place a chair between you and the wall. Then bend at the waist and place the top of your head against the wall, and then you're going to want to try to lift the chair up towards your chest. Then you're going to want to try to stand straight up with the chair in your hands, and then try to pull it up towards your chest. By doing this, you will be able to dictate where your center of mass is. As you can see, my brother tries to lift the chair, and he is unable to do so because his center of mass is higher up in his body. Therefore, the center of mass is over the chair and balanced towards the wall. So when he tries to stand up and lift the chair with his chest straight up, he falls forward.
difference between the center of mass in a male versus a female results in males usually falling because when a male is bent over, his center of mass is over the chair and he is balanced against the wall. When he tries to stand, he falls. When a woman is bent over, her center of mass is still over her feet, so she can still stand.
So there also are some situations where men are actually able to stand up and women are unable to, which can possibly be due to the weight distribution in their body, or it's just the person's body type in general.
In addition to this center of mass challenge, there are others that similarly display center of mass within human subjects, one of which is called the thumb press. In this experiment, students place a chair against the wall so that it cannot slide backwards. They then sit in the chair with their feet flat on the floor in front of them. Your feet may not be angled or slanted to the side during this experiment. They then have a partner gently press one of their thumbs in the middle of their forehead. Finally, the subject tries to stand up without forcing their partner's hand back.
Okay. It's impossible. I can't really do it.
So it's usually extremely hard to stand up in this position because your center of mass is located over the seat on the chair rather than over your feet, which are in front of you.
This widely recognized physics phenomenon displays the intricate details of human bodies and how they affect our center of mass, along with a huge difference between man and woman due to their different center of masses.
Finally, physics experiments such as these take scientific ideas and make them a reality through fun competitions and games, allowing people to have fun and learn physics at the same time.
Thank you for watching and happy physics.